Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss what I discussed in the last class, that is the first order reaction, derivation of first order reaction I have derived. Now I will continue from first order reaction. Here just one thing you should know, that all natural and artificial radioactive decay of unstable nuclei takes place by first order reaction. Question is asked. Okay. All natural and artificial radioactive decay of unstable nuclei takes place by first order kinetics. And plot, what will be the nature of plot? Then if this ln r versus time, if graph is drawn, then it gives a straight line. Okay, ln r versus time, it gives first order straight line. It gives a straight line graph, and where it cuts to the y-axis, that point, from that point to the 0 or 0 to that point, that is the value of ln r 0, means initial ln r of initial concentration. Okay, 0 to the point where this straight line is cutting. Okay, from that up to that point. Then this I told about this is called intercept. This 0 to that point, that is the actually called intercept, and that is the value of ln r0. Okay, and slope, that will give the value of k, minus slope that is equal to k, or k is equal to minus slope, anything. Then slope value how will calculate? Already I told you that this slope is just like a hypotenuse h. Then from any point from this slope, you can make one right angle triangle. Then this slope will be h, and y-axis, that will give the perpendicular, means you have drawn the right angle triangle. Then y-axis, on y-axis, whatever is the value of this perpendicular of right angle, okay, that you can measure it, that will be p. And parallel to x-axis, that will give the value of b. Then tan theta is equal to p upon b, and tan theta is called actually slope. Then whatever we value, that is the slope value, and that slope is equal to minus k. Correct? Then how will you determine the k? Means k is equal to what? It is a constant. This r value not k value, that is equal to minus slope. Then this k value you can calculate very easily. Okay. Now this thing. So one more I want to tell you graph. Okay. This rate constant, easily I told you how to calculate for the this plot between ln r versus t. Correct? Rate constant, that is a k, you can calculate by the graph. Now I am telling you that this plot of log r0 upon r, plot of log 0, plot of log R0 upon R versus time for a first order reaction, if you will draw, then again it will give a straight line, but this straight line will pass through 0. It will pass through 0, means log R0 divided by R versus time. If you will put the data of you can say t at a different time, what was the value of log R0 by R? Log R0 divided by R, and at a different time. If you will put the value, then it will give a straight line. This is for first order, and this straight line will pass through 0. Then again its slope will give value of this plot will give the you can say slope is equal to k by 2.303, k divided by 2.303. Okay, then now again slope value p by b, same way you can make from anywhere one right angle triangle, and p and b value just parallel to the this p. Parallel, if you want to know the value of p, then parallel to y axis, you see, y axis parallel to that line, triangle that perpendicular parallel to that you can see on y axis, and this base parallel to x axis. Just to draw a line, and then you can know the value, what is the time value, what is the this value, log R0 upon R value. Then p by b you will come to know, that is the tan theta, and tan theta is equal to slope, and here slope will be k upon 2.303. This question is asked, both graph they will ask, both graph they will give, and they will ask that for which you can say equation this graph means what. They will ask the question, they will see they will give the graph, nature of graph, and question will be asked, what does this graph means. Then first graph, what I told, that is the ln r versus time. It gives a straight line, and this graph will give the intercept, means ln r 0, initial concentration value, you can get it, correct. And from this graph, from this second graph, ln r0 upon r versus time, that will give slope only, slope. You will not get here intercept, slope. You will get only slope, and slope will be equal to k divided by 2.303. Okay, and here you will get first graph, k is equal to minus slope. This is useful in calculation, in solving numericals. Okay, then already I told you these important things, and also I told you radioactivity, that is of first order. As for example, now suppose radium atomic number is 88 and mass number is 226. Then radium gives helium atomic number 2, mass number 4, and helium will give radium gives actually helium plus radon, Rn, two products it gives. Then radium 88, atomic number 88, mass number 226, and it gives two product, helium and radon. Helium 2 and 2, and mass number is 4, and for radon 86, and mass number is 222. Then here for this reaction, rate will be equal to k into concentration of radium. That is the first order reaction, correct. Rate is equal to k into molar concentration of radium. This is radioactive disintegration, that is of first order. Now again I am telling you decomposition of N2O5 and N2O are you can say examples of first order reaction. Now one numerical I want to tell you. This this type of numericals may be asked in examination, not same numericals. Type, always what I am telling you, that is the type. Only by that concept you can solve other numericals. Value will be different, data will be different, but process will be same. Then now question I am reading. After that I will discuss and I will give the solution also. The initial concentration of N2O5 in the following first order reaction, means N2O5 is giving 2NO2 plus half O2, was 1.24 into 10 to the power minus 2 mole per liter at 318 Kelvin. The concentration of N2O5 after 60 minutes was 0.20 into 10 to the power minus 2 mole per liter. Calculate the rate constant of the reaction at 318 Kelvin. Then here reaction is given N2O5 it gives two product 2NO2 plus half O2, and for this reaction data is given, that is the concentration they have given. Initial concentration for this reaction was initial concentration means R0 1.24 into 10 to the power minus 2 mole per liter, and this experiment was done, reaction was going on at 318 Kelvin, 318 K, and concentration of N2O5 after 60 minutes, means when reaction was going on after 60 minutes its concentration, means now it became first was the initial R0, now this is the R. After 60 minutes value is R, molar concentration of R was 0.20 into 10 to the power minus 2 mole per liter, means two concentrations given, R0 and R, and this initial concentration and after 60 minutes means initial means 0 time, okay, and after 60 minutes value they have given. Then you have to calculate the rate constant of the reaction at that temperature, at the same temperature, means at 318 Kelvin. Then now I told you that for first order reaction there are 2-3 forms of rate of reaction. Then one form which you will use here, that form I am telling you, last class already I told, and graph also I have told you, same basis, on the same basis. Log R0 upon R1, log R0 upon R1, then 0 means initial. Even if 1 and 2 you will write R1 and R2, the R1 means 0, initial concentration, and R2 means after some time. Then R0 upon R you write, or R1 upon R2 you write. Which is less? 1 is less than 2, the 1 you can consider as 0, initial, and 2 as after some time. Then formula already last class I have discussed, that log R upon R0 upon R, or you can tell R1 upon R2, R0 upon R, or you can tell R1 divided by R2, that is equal to K T2 minus 1, T2 minus T1, K, and in the bracket it is there T2 minus T1 divided by 2.303. Okay, this is the formula. Only for this formula I have discussed the plot. Same formula, because here log R0 upon R is equal to K upside. I am talking about numerator, that is the K in bracket T2 minus T1 divided by 2.303. Then here K divided by 2.303 in graph, this value actually we are getting. Slope was equal to K divided by 2.303. Okay. Then by graph also this can be drawn. You can determine the K value. But here question, the data they have given. Okay. Then now here R0 value and R value, both you are knowing. Two concentration they have given, initial concentration, final concentration. Then initial concentration is R0, final concentration is R. Okay. Sometimes in formula or in some other books also they can write 1 and 2, R1 and R2. Then less you consider as always as initial. Then here this R0 value are knowing, R value are knowing, and both temperature, both the time you are knowing, T1 and T2, both value you are knowing. T1 means initial time, that is a 0, and T2 is 60 minutes. Correct? Then all value you are knowing, R0 you are knowing, R you are knowing, and T1, T2 value you are knowing. Then K value easily you can calculate by cross multiplication. Put the value and solve it. Then K is equal to if you want to know the value of K, then say this formula, this form, this is another form of K. Then K is equal to just 2.303 divided by T2 minus T1 log R divided by R0. Just reverse. You have just by cross multiplication you got this value. K is equal to 2.303 divided by T2 minus T1 log R0 divided by R. Okay. Then it is very easy. For actually this form only you keep in mind, because this is the relation directly K is equal to. Then anyway you can shift it and you can get in any form. For main thing is that this relation only. One relation you remember, other you can, same relation you can tell in other form. Then now put all the value. Then after putting all the values, T2 is equal to 60 minutes minus T1 is equal to 0 minute log. Then R0 value is given 1.24 into 10 to the power minus 2 mole per liter, and that is the R0 value, and R value is 0.20 into 10 to the power minus 2 mole per liter. And here I want to tell you, by seeing the value also you can tell which is the R0 or which is the R value. Just by seeing the value, whose value is less, that will be R value, and whose value is more, that will be initial value. Because in the beginning, concentration will be more. Then always initial concentration will be more, and final concentration or after some times concentration will be less. This is one technique in objective type question. They can ask by value, which is the initial, which is the final value. Then you know that with time concentration decreases. Then now I told you only simply just for concept. Then now after putting all this value, you will get after solving all the things, you will get 2.303 divided by 60, because 60 minus 0, 60 only log. After solving all this value, R value, you will get log 6.2. This value is per minute. Then log 6.2 easily from the periodic chart you can see this value, log value or anti-log value. You must know how to see. In examination, university board examination, I am talking about, that chart may provide, okay, but in competitive examination may or may not. Then sometimes for common values you should know, or sometimes they will give this log value directly, that log 6.2 is equal to what, they will give only in question sometimes. If not, then they will give such type of question that that value might be in common value they will give, like log 10, log 2, this is common, log 3 is also common. Up to 5 you should remember. 2 already, like 4 you will not remember. Log 4 means 2 power 2, 2 log 2. Then log 2, log 10, log 2, and log 3 and log 5. This you always keep in mind, remember. If any other value is required, then they will give the value of that log. Only in question they will give log this is equal to this. As for example 6.2, then they will give in question log 6.2 is equal to this. Okay, log 6.2, as for example you can say this 6, very easily you can say this is not anti-log, easily you can know. Then after multiplying all the things, you will get K value, that is equal to 0.0304. okay, then like that way you will come to know that K value means rate constant. Then now I have discussed that if it is in concentration reaction, in reaction you are using concentration, liquid form, solution form. But now I am going to discuss if reactions are taking place in gaseous medium, then already I told, in that situation partial pressure will be equivalent to concentration, ATM, atmospheric pressure. In short, it is written ATM, small a Tm, atmospheric pressure. Then it will be equivalent to concentration of the solution, because gas is measured in pressure. That's why just it is the equivalent to concentration. But here you will use the partial pressure of the gas. Then I am giving concept now if reaction is going in gaseous form. Now in general way, just you consider a typical first order gas phase reaction. Suppose gas A, capital A, is giving two products, B and C, both are gas. Reactant is also gas, products are also gas. Means A is giving B and C, all three are reactant as well as products, all are in gaseous phase. Then now here you have to understand the pressure, different pressure. Let P1, either a small P1 or capital P1, it depends upon you, you consider whatever way. Let P1 be the initial pressure of A, and this P1, a PT, T means total, and PT the total pressure at a time T, correct? P1, or for the initial pressure Pi you can better consider. I means initial, Pi means initial pressure, I you consider. Then let P-1 be the initial pressure of A, and P-T, T means total, and P-T the total pressure at time T, at any time T. Then after that, what will happen? Integrated rate equation for such a reaction can be derived as how? I am telling you now. Then total pressure is equal to now. Total pressure means PT is equal to pressure of A plus pressure of B plus pressure of C. Okay. That is a total pressure. Total pressure is equal to pressure of all three, A, B and C. That is called total pressure, PT. Total pressure, PT, that is equal to PA plus PB plus PC. Okay. Now this total pressure, now you are knowing. Here you should know concept of partial pressure. Partial pressure means, suppose now here mixture of three gases are there. Reactant and products are all in gaseous phase only. Then due to one gas, what is the pressure? Due to one gas in the mixture, always partial pressure is related to the mixture of gases, always. Then pressure due to one gas, what is the pressure due to one gas? That is called actually partial pressure. Then in comparison to the total, what is the pressure of any one gas? Any one gas. Then that will be individual gas divided by total pressure. That is called partial pressure. Okay, this concept don't forget meaning of partial. Any individual gas, pressure of any individual gas divided by total pressure. Then now you have to understand by keeping this concept in mind. Then here PA, PB and PC are the partial pressure of A, B and C respectively. A, B and C gases respectively. Now another things you are going to consider. If X atmospheric pressure, if X, small x you can consider, or capital X, that does not matter. If X atmospheric pressure, you can say be the decrease in pressure of A, because when reaction will start, then pressure will decrease. Just like concentration decreases, here pressure will decrease. Then suppose now X atmospheric pressure decreases. Okay. In pressure in can say A gas, pressure of A gas decreased. Suppose X atmospheric pressure, maybe 0.1 atmospheric pressure ATM, 0.2, 0.3, 0.4, like that way. That way you don't know exact you don't know. That's why simply you tell X decreased. Then here this pressure decreased at can say at a time T. At time T, after sometimes means after sometimes T time, now pressure decreased. Pressure of the gas, that is the reactant here, only one reactant, A gas, that decreased. Then what is the remaining will be there? Remaining pressure of gas A. Then gas A, actually PA, PB, PCS, a small PA, a small PB, a small PC, that is the partial pressure, keep in mind. Then now what is that decrease? X atmospheric pressure has decreased. Then what is the remaining pressure of gas A? Remaining pressure of the gas A. That from the pressure of gas A, this pressure you have to deduct. Then that will be the remaining pressure. that then that things you have to consider. And this, suppose you are considering all, you can say this 1 mole, suppose you have taken each gas. This gas A it converted to gas B and C, and it has given 1 mole each of B and C, correct? Then here A is giving 2 products, B and C. Then when time was 0 in the beginning, what is the A? What is the pressure of gas A? Then it is the P1 atmospheric pressure, ATM, P1 ATM. Okay, and B and C in the beginning it was 0 because 0 time means no reaction, no decomposition. Hence B was 0 ATM and C was 0 ATM. Now at time t, means after some times, at a time t, now X mole or X ATM you can tell, not mole, X ATM. But for the theoretical concept you can give equal mole, they will give. Okay, A, B and C they have given equal mole means here equal pressure they have given equal. Then now after some times P1 minus Pi initial pressure, Pi minus X will remain after some times, because initial pressure of A was Pi. Initial pressure of gas A was Pi. Then now Pi minus X will remain. And what will be the B and C? Then same. X ATM, X ATM. X ATM B, X ATM C. Okay. Where Pi is the initial pressure at a time T0. That already discussed. Then now here you want to know the value of total pressure. Then it is very easy. PT you want to know. T means total. Then very easily you can determine that now after some times total pressure will be what? Then what is the remaining pressure of A plus pressure of B plus pressure of C, means Pi minus X, that is for A, plus X, means for B X and for C X. Then now if you will add all 3 pressure, then minus X plus X will cancelled out, and we will get Pi plus X, because this A has Pi minus X pressure plus X, then 1 minus X, 1 plus X will cancelled out. Then what will remain? Pi plus X. That is the total pressure. Then from this relation means PT is equal to Pi plus X. Then now you can get the value of X. X is equal to what? PT minus Pi. Correct? PT is equal to Pi plus X. Then X is equal to what? PT minus Pi. Pi bring to the left side. Then PT minus Pi. Okay. PT, that is the total. Then now here you got the value of X. Then now here PA value. Now you want to know the PA value. Pressure of gas A. Then how will you come to know pressure of PA? Then PA equal to pressure of gas A, that is equal to Pi minus X. Pi minus X, that is the pressure of gas A. You have considered all the things, correct? After time t, Pt minus x, that was the partial pressure of A. Then now Pa is equal to Pt minus x. Then now you put the value of x, already calculated. X is equal to Pt minus Pi. That value you put here. Then now you will get that is the Pt. You will get here Pt minus x value you put. The next value is x value is now Pt minus Pi, already calculated. Then now here what you will get, that now minus, if you remove the this thing's bracket, then minus plus. Then now you will get here that 2pi minus Pt plus Pi, 2pi, then Pi plus Pi, 2pi minus Pt, 2pi minus Pt. Was a bracket you are removing, then minus will come plus, then Pi plus Pi, 2pi minus Pt. That is the partial pressure of gas A, correct? Then now partial pressure of gas A you are knowing. Then K value you want to calculate. Then already you know how to derive the K value. Then same formula is same. K is equal to 2.303 divided by T. Either you write only T or you write T2 minus T1, same things. T is in general. Okay, if 2 time is given, then T2 minus T1, otherwise only T write. T at time T. Then 2.303 divided by T, log already told you R0 divided by R. R0 divided by R. Then here R0 means in term of pressure. That is the initial pressure you have to write. Then here you should write, here initial pressure is Pi. Pi is the initial pressure divided by Pa. Okay, means after some time pressure, that is the Pa. After t minute or at t already calculated, that value you have to put here. At t what was the pressure, that now we are considering as a Pa. At time t you consider, that is better. Concept you keep in mind, initial divided by any time. Then any time pressure is Pa. That is for reactant you are considering, reactant, not the product, reactant. Then now you put the value of any time pressure. Then any time pressure is already calculated, Pa 2Pt minus Pi, 2Pi minus Pt. Okay, 2Pi minus Pt, already you have this value calculated. Okay, 2Pi minus Pt. Then K is equal to, now you got 2.303 divided by T log Pi, initial pressure, divided by pressure at a given time. Then here 2Pi minus Pt. This concept is very useful actually generally for IIT Advanced. This question they will ask based on this formula. Based on this formula, many questions they have asked and will ask also. Hence, use of this formula is very important. Okay. Now I am just discussing one numericals based on this formula. Okay. Then question I am reading you. Then you can use this formula. After that I will give solution or I will explain it. Then now question I am reading. They have given one this thing, relation and reaction they have written. Question I am reading. The following data were obtained during the first order thermal decomposition of N2O5 at constant volume. Whenever you will talk about the pressure, volume will be constant. Keep in mind. Okay, because you are going to use the pressure, then volume will be constant. Now again I am reading the question. The following data were obtained during the first order thermal decomposition of N2O5 at constant volume. Reaction is given 2N2O5. It is giving two product N2O4, 2N2O4 plus O2. 2N2O5 is giving two product 2N2O4 plus O2. All are gaseous. Reactant is also gaseous, gas, and products are also gas. Then data they have given that first data, that is when time is 0, total pressure is 0.5 atm total pressure, and when time is 100 second, in 0 second means initial pressure is 0.5, and at 100 second pressure is 0.512. It has increased. Okay, then these two actually data is given. Calculate the rate constant. K value you have to calculate. Then now I have discussed the relation that K is equal to 2.303 divided by T log initial pressure divided by pressure at given time, pressure at a particular time. That also in another way written 2.303 divided by T log initial pressure divided by 2 Pi minus Pt. Means you require two things. Total pressure is required. Total pressure Pt you required and initial pressure is required. Then in question both are given. Okay, means 0 time value is given and 100 seconds value is given. Then it is easy to calculate. Then now how will you calculate? I am telling you. Let the pressure of N2O5 decreases by 2x. Okay. Suppose this pressure N2O5 decreases by 2x atm. As 2 moles of N2O5 decomposes to give 2 moles of N2O4 and 1 mole of O2. The pressure of N2O4 increases by 2x, and that of oxygen increases by x atm, because reaction they have given 2N2O5, it is giving 2 mole of N2O4 and 1 mole of oxygen. That's why that time you have written x and x, and when I was explaining that time, that was both A and B we are giving that time x atm, P1 atm. That time you consider x atm. Better you consider both were giving equal. But here according to the reaction both are not equal. One product is 2 mole, other product is 1 mole. Hence when x mole when x mole will decrease, then 2 into it will give double. 2 into x by 2 it will give. 2 into x by 2. Correct? Or better you understand like this, that 2x is decreasing. Better, it will come in round figure. 2x press ATM decreased. Then how much it will give? Then it will give actually 2x ATM of N2O4 and x oxygen as per equation. Equation is 2N2O4 plus O2, means it will give 2x and x when 1x will decrease. Okay. Then here means it is becoming N2O4 is becoming double. It is becoming double. In the beginning, when this was there, 0 concentration was there, then that time pressure was 0.5. Means the initial time when time was 0, then N2O5 pressure was 0.5 atm as per question. N2O5 was 0.5 atm and 2N2O4 plus O2, that were 0 in the beginning. In the beginning, before decomposition, both products were 0. But after time t, at time t, suppose 2x decreased, 2x ATM decreased, then what will be the remaining? The remaining will be 0.5 was in the beginning, initial, then 2x decreased, then now remaining will be 0.5 minus 2x ATM will be remaining. And what will be the product? Then as per the reaction, it is giving 2N2O4 plus O2. Means N2O4 is 2 mole and O2 is 1 mole. That's why in the same ratio as per the reaction, in the same ratio it will give 2 mole of N2O4 and 1 mole of oxygen. Means 2x is giving, 2x decreased means 2x N2O4 will give and x oxygen will be x. Same ratio. Don't confuse. That is the 2x you have considered decreased. Then it will give 2x. It will give N2O4 and 1x, that is the oxygen as per reaction. This is the only things you have to understand. Okay. Then here that remaining, at a time t, what is the pressure? Now you are knowing the total pressure. You have to calculate total pressure, all three pressure. Then 0.5 minus 2x, that is for N2O5 plus 2x plus x, all three now you add. Then after adding, then this minus 2x plus 2x will cancelled out. You will get 0.5 plus x. 0.5 plus x, that is the total pressure. Then in formula I required initial pressure and total pressure. Then our total pressure value you are knowing. Then from this relation, from the total pressure, x value now you can calculate, because now you got Pt is equal to 0.5 plus x. Then what is the x value? Then x is equal to now you got this things Pt minus 0.5. Then now x value you are knowing. Pt minus 0.5. Then now this N2O5, what will be the N2O5 concentration? At time t, what will be the concentration. Then you have considered 0.5 minus 2x. At time t concentration was 0.5 minus 2x. Then now you put the value of x value now you have calculated. X is equal to Pt minus 0.5. That value put here. Then now we will get the value of pressure of N2O5 at a time t. Then after putting the value of x, you will get 0.5 minus 2. In bracket you write Pt minus 0.5. X value you put. After that, after the solution, you will get 1.5 minus 2pt. Okay, you will get a value, this thing, 1.5 minus 2pt you will get. This is the N2O5 pressure. N2O5 pressure. Here also you are doing the same things. You are N2O5, you want to know the pressure. Then now you are knowing pressure. P2O5 pressure is 1.5 minus 2pt. Then now this is the pressure of N2O5. Okay. Then at time t second means 100 second. At 100 second pressure is given. At t second pressure is given in the question 0.512 atm. Correct? Then now pressure of this initial pressure now you are knowing. Okay, and at a time t, this not initial pressure, you have to put actually pressure of N2O5, that is 1.5 in minus 2pt. Then pt value you have to put here, t value. Then total value pressure at 100 second, that value is given in question. That is a 0.512. That value is given. Then what will be the value of N2O5 after putting this value? Then 1.5 minus 2 into 0.512. Then you will get 0.476 atm atmospheric pressure. That is for N2O5. Then now all things you are knowing. K is equal to, wanted to calculate the K, then K is equal to 2.303 divided by T. Then here T is equal to 100 second. Log here initial pressure divided by pressure of A. Okay, pressure of A. Then this value will get, already initial pressure is, in the question it is given 0.5 atm. Correct? Initial pressure is given in question, that is 0.5 atm, and at any time, that is the PA. That is the PA, pressure of gas A, any time. Reactant A, any time. Then now you have calculated PA, N2O5, pressure of N2O5, that is the 0.476. Then now all things you are knowing. Then now it given 2.303 divided by 100, and after putting the value log 0.5 divided by 0.476, if you put the value of log 0.5 and log of 0.476, easily you can see from the chart, then you will get, after putting the value, will get 0.0216. Then now easily you can get the final result, means 2.303 divided by 100 into 0.0216. Then you will get final result 4.98 into 10 to the power minus 4 per second. Okay, this you will get the result. K value now you got. Understood? Then this actually, this you have solved the these things. You got the value of K. Now I am going to discuss these things, half-life of a reaction. Half-life of a reaction. I think now time is becoming more. Okay, next class I will discuss. Thank you.